As we understood details with respect to case classes, now let us go ahead and create datasets from RDD. So here I'm connecting to that Windows machine and launching Spark shell. Let us create a variable called input base directory. It should be pointing to mnt c data retail underscore db, and then we'll be creating a variable called orders, and then we'll be reading data using sc.text file by passing this input base directory and concatenating with orders. Before going further, let us validate by saying orders.first to see that the path is correct. You can see the first record here. Now we want to create a dataset from this RDD. So this RDD contain string elements, you can see here. To actually convert this RDD to dataset, we need to create case class first. So we'll be copy pasting the code to create the case class, as we have already seen details with respect to case class. As the case class is created, let us also create a order object just to see how we can access the elements from this case class. You can actually say o._1 to get the first element in the case class. Sorry, you can say o.hit tab to get list of APIs that are available as part of this case class. On top of getters and setters, such as order customer ID, order date, order status, we also have product APIs. So we can use product arity to get the number of elements in this object. There are 4 elements. We can also read a particular element by saying product element and then by passing the position of the element. So if I say off 0 here, we will get the first element. If we say off 1, we will get the second element, so on and so forth. We can also convert this case class object to a collection by using product iterator. So I can say o.product iterator. It will return a iterator of any, and it contains the elements as a collection. Once we convert into iterator, we can actually apply any list or collection based APIs on top of it to process it further. One of the common usage of this product iterator is once we convert into collection, if we want to create the object of type string with a different delimiter, we can use a function called mkstring, and then we can actually pass the delimiter. So in this case, our original data was comma delimited. By using this, we have converted into a string with tab as delimiter. So these are some of the usages of the case class using the APIs that are available because of the implementation of product. That being said, now we have to use map on top of our orders RDD. So orders is of type RDD, and we can apply map function. And as part of the map function, we can split it using comma as delimiter, and we can create it as a order object, and then we can take it from there. So in this case, I am saying val orders ds equal to orders.map, and we will process each element as order, and I want to write multiple lines of code, and hence I am opening curly braces here. And then we can actually create a new variable called a or o, whatever name you want to give, you can give, and then I will be splitting the order using comma as delimiter. Now a will be of type array, and it will contain all the elements that comes as part of each of our order records. Now I can use order. So in this case, I am invoking order.apply, and we can say a of 0.toInt because the first element in orders records is nothing but of type integer. Second element can be read as a of 1. Third element can be read as a of 2, and again it is of type integer, and hence we have to typecast to integer. And then a of 3, which is nothing but order status. Now we can close this, and it will actually return an RDD, and each element in that RDD is of type order object. So each element in this RDD is a object, and it is of type order. Now to convert this to data set, we just have to say 2ds. As long as RDD contains elements of type a particular object, we can invoke this 2ds function, and now orders ds will become a dataset, and it will inherit the schema from the case class which we have created. And we can see the definition of case class here. We have 4 elements, and the first element is order ID, and it is of type integer. Second element is order date, which it is of type string. Third element is order customer ID, it is of type integer. And fourth element is order status, it is of type string. Now orders ds inherit that as schema. You can actually say orders ds dot print schema, and you can see the details. You can also say show to preview the data, and you can preview the data. So this is how you can actually convert an RDD of type a particular object into dataset. The major difference between dataset and dataframe is dataframe can be processed using dataframe operations or Spark SQL. Either approach can be used to process the data in dataframe. Dataset is also work in the same manner. Dataset is lookalike sibling of dataframe. There are so many common features between the two. However, one of the differentiator between dataset and dataframe is that we can actually process data in dataset using traditional MapReduce APIs also. So once the dataset is created, we can say orders ds dot map, and then we can actually say order implies order dot order id to get the order id from the data. It should be order underscore id, and you can say show to get the results. So this is traditional map API which we typically use as part of core APIs. Map is the transformation and we are using that transformation. However, if we create a data frame, let's say we convert this data set to data frame. I think using 2DF we should be able to do that. And if we say map, and if we actually try to apply any transformation logic such as this, which worked with data set, will not work with data frame. You can see that it is saying value already is not a member of org.apache.spark.sql.row. There might be a way to process, but it is not very straightforward. Typically, data frames are used only to process data, either by using data frame operations such as select, filter, where. Filter and where are synonyms when it comes to data frame operations. The filter which we see as part of data frame operations is different from RDD filter. And then we use group by to group the data by a key on data frames. We can perform aggregations, so on and so forth. We can also register the temp table, and we can actually run queries also on top of those temp table, which is created off of data frame. So the major difference between dataset and data frame is datasets can be processed not only with data frame operations and Spark SQL, but also traditional core APIs such as transformations and actions.